What's up, everybody? Today we're going to do a fun topic. This is compilations. Compilations. And I'm pretty excited about it because we get to actually talk about some computer stuff. Like, the last two videos were kind of like a little bit like what I like to call IT. Um, it's just sort of like, this is how you use things, and you type in this command, which is important to get you started. But we want to talk about how things work and why they work and stuff like that. That's the interesting stuff. So, um, where we last left off was we wrote a program, and it's a C program. We called it hello.c, and now we want to run it on our computer, but I told you we couldn't do it yet because we had to go through a process called compilation. And you might be like, well, why do we need to go through compilation? And really what it boils down to is we need to be able to talk to the machine, right? To the machine, and we need to use machine language. And this kind of goes to the heart of like, what is a computer, right? Like, at the end of the day, a computer is an electrical device, right? It's a piece of electronics. And it works because we plug it in and it gets powered on. But there's no like magical pixie fairy in there who's like giving sentience to our computer, right? Our computer just like behaves in accordance with the laws of physics as they dictate how our electrons flow through our circuitry, right? So the computer really only knows, it doesn't know anything really, but it really only behaved in accordance with whether or not certain things have electricity flowing through them. And that's a pretty broad simplification, but there can really only be two states. We can have it be that, one, there is some electricity. I'm just going to put electricity. And then 0, there's no electricity. Right? Now you may be like, I know where you're going with this, because you've probably heard of binary, right? And you've probably seen in movies like guys just looking at giant screens filled with ones and zeros, and you're like, how could they possibly know what's going on with that? And the truth is that they can't, right? That's Hollywood, that's nonsense. But it is a grain of truth to it in that a computer only understands ones and zeros. And we can only tell a computer to behave based on, binary or machine code, right? And as sort of an interesting aside, I just want to point this out. It's kind of tangential, but if you've ever seen this symbol, right, that is your power on symbol, right, on your computer. And you may be like, well, what is that, right? It's a 1 or it's a 0. So that button is to toggle between 1 and 0, and it's to turn it on or off, right? So I just thought that was sort of an interesting tidbit. Anyway, so we need to communicate with the machine, but it's super crazy to write binary. In fact, I grabbed a piece here, and there's two things I want to point out real quick that are sidetracked. Is one, that if you're running VI and you already know what program or what file you want to open, you can just write the name of the file as the command argument and it'll open. I think I did that last time but didn't explain it. So you don't have to open it just with a new file every time. You can open a file that you've already saved. The second is that if you don't want to type the whole thing out of a file name, you can hit tab. So like if I only have one file in my directory that starts with a B and I hit tab, it'll be like, oh, you mean binary text. So those are just two sort of things. I said I'd kind of point them out as we went along. So those are two little things to note, shortcuts. But anyway, getting back to the point, right? This string of mostly zeros but some ones in there is actually a command in binary, and it is to add two numbers together. You might say, wait a minute, which two numbers? Well, it doesn't tell you which two numbers. It just says that there exists a number in this registry and a number in this registry, and I want you to add them together and store them in this registry, right? And that's pretty crazy. And the only reason that I know that is because I Googled it for this tutorial, right? Like, you don't have these kind of things memorized. That's nonsense, right? And if you had a whole giant page of just ones and zeros, like, you wouldn't be able to pick this out and be like, oh, they're adding, right? So like nobody does nobody writes binary, but the machine only understands binary. So that brings us to our compiler, right? Because we have a computer, we have a CPU, and we've got a person, and these two people, these two objects, need to be able to communicate with each other. And I can't understand what you're talking about, and you can't understand what I'm talking about. So we need some way to communicate between each other. And there are a few different ways to do this. It doesn't have to be a compiler, but one of the most common ways is, a very common way, it's actually, interpreters are becoming more common. By the way, if you want to quit something but not save any of the changes that you made to it, you can hit :Q exclamation mark, which is often referred to as bang. So, I mean, I didn't make any changes to this file, and it doesn't matter if I did because it's not an important file. But if I had a file open, if I have a file open that I didn't want to make changes to, I generally always Q bang to get out of it, just in case I accidentally change something. So, anyway, again, getting off topic. Back to people. We need to compile our code down to the machine language. And so that's what a compiler does. It's a program that takes input. This arrow is misleading. It's a program that takes some high-level language, let's call it, in this case, C, so person.c, right? It comes in, and then it spits out some machine-level executable file that our CPU can read, understand, and execute, right? So at this point, you may be asking, if you're, a thinker, well, if programs are all compiled by the compiler, then who compiles the compiler? Oh no. And that's a good question. The answer is kind of that it's turtles all the way down. There are some examples that I've read about where people have written compilers that compiled themselves, sort of in like as they were running, they were compiling themselves as sort of their own interpreter. But generally speaking, when a compiler is written, it is compiled by an older compiler, right? So it just keeps going back. Like, I wrote a new and better compiler and I compiled it in an older compiler, and it just keeps going back until at some point you've got like punch tape readers and Alan Turing and shit. But this drawing makes a lot of sense, by the way. So anyway, we don't need to know about that much. This is not a tutorial on building compilers. That would be insanity. We just need to know how to use one. And so in this video, I'm going to use the GCC compiler because that's the one that comes default for, guess who? Guess who it comes default for? For Linux and Mac, you can use the GCC compiler. Windows, whole separate thing. I'm going to do an entirely separate video, the next video. But if you're Windows, stick around because I'm explaining the theory of, well, I've already done it, so I guess maybe you can switch from here on out. But, it's good to get the theory even if you can't use this particular compiler, you know about compilers, and that's great. GCC stands for the, GNU compiler collection, and the G stands for GNU, which is funny to me because GNU stands for GNU's not Linux. Or not Unix, sorry. So the G in GNU stands for GNU, which is just sort of keeps going forever recursively, which is funny to me. Anyway, we can use our GCC compiler we don't have to download it, anything like that, because it's built in. And we run it like any other program that we want to run, GCC, and we pass it our command line argument, which is the file that we want to compile, which is hello.c, and we hit enter, and nothing happened. That actually took way longer than I thought it was. I must have too much stuff running, because it's good that nothing happened, because if generally when something gets printed out by the compiler, it's bad news, right? Like if there was an error in your code, the compiler will be like, it's broken, and or maybe it's just a warning, which is not as concerning, but you should probably still look into it. Anyway, I got no errors, so that means my code compiled successfully, and if I open it, you can see that I made that. That's those zeros and ones I was showing you. This a.out file. And you might say, like, well, why is it a.out? A.out is just the default output file, because I didn't specify a name for my output file, which I usually don't. You can, right? If I wanted to name it, I could say gcc hello.c. I could set a flag -o is a flag that means output, and then the name, what I want to call it, like I'll call it my hello program. Usually for like code like this, and see now I've got a hello program, and usually for code like this I'm not going to name every single one, right? I'm just going to use a.out because it's fine. But if you want to name your programs, you can. I do try to name my C files what's called your source files, with useful names, so that you can refer back to them and be like, oh, this is the code that I wrote that says hello, right? And speaking of the code that we wrote that says hello, let's run the damn thing, right? It's been 3 videos, so we can. Which one? Let's run hello. They both do the same thing. Let's run hello program, right? Like, because we're going to run it like every other program. There's one caveat though. We do have to put a / before it. You might be like, why? Is there something wrong with our program that we can't just run it like other programs? Well, it has to do with how the bash terminal looks for folders, looks through folders. Actually, in Windows, hey, Windows people, something that's good for you. You don't have to put / because the command prompt looks in your current working directory first for whatever program it's going to run, but bash looks in the root directory, and if it doesn't see it in the root, it's going to be like, you don't have that. And most like professional programs, when they install them, they make changes to your bash so that it knows where they are. But that's a lot of extra steps to do just to run this hello program. So we're just going to put / and that tells bash to look in the current working directory. So it's nothing bad with our program, it's just that we haven't set up all the stuff behind the scenes to make it run independent of the directory. So we're going to put / and there it says, hello YouTube, ! So we have officially written a program, compiled that program, and then run that program. And it only took us 3 YouTube tutorial videos to do it. But now that that's done, now that we have an understanding of how it works, we can go back and explain. First of all, I'm going to go back and explain, like what all I wrote, what all this does. But I am first going to make a video for Windows people to have a compiler that they can use, right? Because GCC doesn't come on Windows. So I'm going to do that video, and then we're going to really get in there and write a bunch of codes and learn all the things. So super excited, and bye for now.